So just a brief introduction. So hi everybody, my name is Dave Scott. I'm currently, until hopefully tomorrow, a master's student at the University of Alberta. Tomorrow morning I have my master's defense, and I did my master's in something called Computer Process Control Engineering. And so my presentation is titled Applied AI in China. How did a chemical engineer win 3 hackathons in 6 months? And so first, I'm going to start with a bit of an executive summary. So I'm going to talk about growing up here in Edmonton and studying my bachelor's degree at the University of Alberta. And then I'm going to talk about my transformation from my bachelor's degree in chemical engineering and then to where I'm trajecting myself now, which is more in applied machine learning and as well as data science. And then continued learning, dedicating myself for an exciting international career because that's where my next steps are heading. So firstly, my education. Growing up in Edmonton, I spent much of my youth obsessed with emerging technologies. So oftentimes what that meant for me is just playing like Xbox 360 games, and as well I had like a really strong passion for sports. So what was happening with me is that I was really keen and curious learner, and so with a lot of my electronics, I would just take them apart whether they were broken or not. And pretty much from that is I just got this kind of appreciation for trying to like figure out why things work the way that they do. And so then at age 13, my curiosity to modify my electronics led me to my first entrepreneurial ventures. So basically what I did is I created a business purpose to make players more competitive in online games without actually becoming better players. So this is where it led me. I modified my Xbox 360 controllers using a programmed 8-pin microchip. And then basically what I did is I soldered wires between the 8-pin microchip to the left and right triggers. So essentially how this works is on a controller, you basically, if you're playing a first-person shooter game, you press your triggers back and forth in order to make a gun shoot. But instead what I wanted to do is I wanted to use a push button instead of this operation of pushing the triggers back and forth. So pretty much what I did is I would solder one of the pins to the left and right triggers, and then one of the pins to a power source, and as well one of the pins to a push button. And then on the back of the controller, I utilized my dad's drill to drill holes on both the left and right backhand sides of the controller. And then I used my sister's hot glue gun to hot glue the push buttons in. And then afterwards, I had my first prototype that worked well. So from here, this basically gave me the opportunity to have a viable business. And I would sell my controllers back on eBay. And then after I did this, I was hooked on testing and trying new things in regards to technology. So this led me to choosing a degree in engineering. And so why did I choose chemical engineering to begin my engineering degree? So problem solving. I wanted to extract insights from a wide variety of problems, determining the who, what, when, where, why, and how of the problem. And as well the connection. I always have felt that I'm a very people-oriented person, so I want to have a connection between business goals and as well customer objectives to develop solutions that address systematic issues. And finally, the readiness. Working in the chemical engineering industry, especially here in Alberta, is a very intense and fast-paced industry. This taught me to always be ready and agile on my feet and being able to adapt to the market as it occurs. However, the 18-year-old's true reason to choose chemical engineering, I was a lazy student and I didn't go to all the first-year nights. So all I did was I went and looked at APEGA's salary guides, and I saw that chemical engineers were some of the highest salary earners here in Alberta. So that was my true motivation for choosing chemical engineering. But this left me with a bit of a problem because I realized that I love technology, but chemical engineering is a bit of a static industry in the sense that they're not always willing to upgrade to new technologies. So this left me with a problem in 2017. How can I transform myself from being a subject matter expert in chemical engineering to a machine learning engineer that utilizes data science and programming? And to solve this, I came up with a bit of a transformation and adapting plan. First, I wanted to focus my master's that concentrates on machine learning. Secondly, one thing that I've always felt is very important is networking and trying to diversify yourself compared to your peers that are at the same point in their careers. And finally, always having continuous learning and trying to push boundaries as much as I could. So for me, what this meant is I undertook my master's in computer process control engineering under Dr. Biao Huang at the University of Alberta to grow my coding base and influence how machine learning can be applied into industrial processes. Secondly, during my first semester in September 2017, I took my second introductory class on machine learning, and I really discovered a strong passion for machine learning and realizing that I could actually improve my coding skills through everyday practice, whereas beforehand it was something that I had struggled with. And then once I began my master's research in January 2018, I discovered a particular issue with industrial process monitoring, where most machine learning algorithms can only handle non-stationary data or stationary data. Thank you. So this might leave you to ask, what is non-stationary data and what is stationary data? And essentially, this is how it works, is that in an industrial process such as this is a vapor recovery unit for sulfur. So what variables are produced and how are they monitored to detect changes? So this is stationary process data, and for us, this is actually really nice data to work with, and there's lots of algorithms that some of you might be familiar with that can be applied on this, such as principal component analysis. Whereas with non-stationary data, it's actually extremely difficult to work with because it's sort of like predicting a stock price on a market. So we need to find some kind of way that we could utilize both stationary and non-stationary data in an industrial process at the same time and model it. So as I was mentioning, is the problem. Not all non-stationary processes can be monitored by leading methods, and then the stationary or the methods that are good for stationary processes cannot monitor stationary data. So the goal was this: could I create a framework that monitors both non-stationary and stationary data for industrial processes? And then how to solve the problem? Well, I was sitting over here in Canada, and then the subject matter expert for the machine learning algorithm that I was trying to develop was actually in Beijing, China, over here. So this led me on a bit of a journey. I actually went and did a 6-month master's exchange at Tsinghua University in Beijing this year. So it was a great opportunity for me to basically have my subject matter expert there and be able to ask him any questions that I had developing the algorithm. And so going back to transforming and adapting, how to come over issues, or how did I overcome issues basically in designing machine learning algorithms and data science application without having a background in computer science? So for me, this is a bit of like a what and a how. What? We had highly correlated stationary and non-stationary process variables. And in order to basically adjust and adapt these, we had to modify the slow feature analysis machine learning algorithm to handle both non-stationary and stationary process variables, because this is something it wasn't capable of doing beforehand. And then we wanted to implement the proposed algorithm on simulations and industrial processes. And then in order to do this, we had to test and validate performance by utilizing other important algorithms such as principal component analysis. And this is just a little bit of the mathematical formulations for my master's research. So we won't go into too much details with this, but essentially beforehand is that we just had it in a way that we would only calculate singular slow features, and this is what's called like a state space formulation. But pretty much the juice of the master's research was in the sense of that we basically had a way that we set up our state space formulation that we can utilize both non-stationary and stationary data together and basically have it in one singular module process, whereas beforehand, the most leading methods, what you would have to do is you would have your non-stationary process data and you had to do ways to convert it to stationary data, and then afterwards you could then analyze it. So this basically saves a lot of the time and hassle and computing complexity in that. So my exchange in China, a bit more on this. And this is just a little bit of kind of personal information. So my exchange in China, some of my takeaways. Firstly, being able to learn Chinese on an everyday basis and have the ability to practice with my friends. I had an awesome opportunity arise. I was sitting in one of my meetings one day and one of my professors had noticed I was writing the pinyin as my friends were talking. And then he just asked me if I was interested in learning Chinese, and I said, of course, yes. So one of my lab mates took me to like a Chinese language school that weekend, and then I started taking language classes every day. So basically, for about 5 months, I studied for 1.5 hours a day from Monday to Friday. And then in my spare time, I'd always be talking with friends and as well doing lots of reading and writing and whatnot. So I actually started learning in March, and I wrote my HSK 3 in August, and I'm writing my HSK 4 in January. So I'll be classified as an intermediate Chinese speaker now. And then one of the most important parts of this presentation was joining hackathons to implement and basically have the opportunity for me to learn and grow my skill sets. My master's research, I didn't touch on computer vision and natural language processing very much, but they were they're areas of interest to me. So I always noticed that the hackathons at Tsinghua, there was lots of application for computer vision and natural language processing. So I wanted the opportunity to join them, and so I could learn. And of course, the delicious food. Chinese food is the best. I love the food so much, and yeah, I'm looking forward to going back to Beijing and keep eating. And I wanted to talk about some of the most interesting AI-related applications that I saw while I was living in China. So I think one of the coolest ones for me was the Alipay payment stations, or the point-of-sale systems. And so here, essentially, how it is, or how it's working, is that you could either utilize your phone and based on Alipay or WeChat, you can scan your QR codes, and basically that's a way to pay. But for example, if you actually didn't have your phone with you, there's certain applications that you can actually just utilize your face to pay. So for example, I was out buying bread with one of my friends one day, and she didn't have her phone with her, but all she had to do is there was a little small on the table, basically like a facial recognition, and all she had to do was basically look at it like this for about 4 seconds, and it scanned her face, and then it automatically take money out of her Alipay account to pay for bread, which I thought was pretty incredible. This one, and actually there's a video with this too. I'll just start this video and then I'll talk about it a little bit. So this basically is an application in an airport, and it's for facial recognition. But one of the things that I found really interesting is as a foreigner, it was even able to scan his face and basically tell exactly where he was going. So he was going from Chengdu to a different city, and basically it knew everything about his boarding pass and his application just by scanning his face, which I found pretty interesting as a foreigner because I had known about the Alipay system beforehand for like Chinese nationals, but I found this one quite interesting as a foreigner, but just kind of showcasing some of the advances in AI in China. And one more. Oh, sorry, let's see. Okay, there we go. And then this was a really cool one. So actually, this was out of my Department of Automation at Tsinghua University. But basically, there was an autonomous bicycle. So they had first created this bicycle with gyroscopes and other instruments in 2016, but they actually went and then applied AI chips on it afterwards. And so basically this bicycle is fully autonomous, and it can go over multiple different faulty case studies, like going over bumps and whatnot. And I was really impressed with this. And so this was, people were doing this just on the floor above where I was working at Tsinghua University, and like, yeah, just brilliant people at Tsinghua. And so my experience in hackathons. So I'm going to touch a little bit about some of my experience in hackathons in China. So this is part of the continued learning. So I'll talk about the 3 different hackathons that I participated in and just give a bit of an introduction on each. I participated in the Tsinghua University Internet of Things Hackathon in May 2019. And so for this, we had to just develop an IoT solution for a problem. So our solution actually came from a bit of an inspiration from a pilot project here in Edmonton, actually. Because I remember the city of Edmonton, they had created this pilot project where basically they wanted to see which vehicles had the highest noise pollution. And you guys might be familiar, they placed these basically decibel meters on White Avenue and on Grote Road. But then afterwards, what I remember happened is that people would just drive right beside them and rev their cars to see how high they could get the decibel meter to go off. So they didn't actually have like a very good way to enforce like how the decibel meter was reading. So I was sitting at a cafe with my friends, and this was like after the problem statement came out at 10 p.m. at night. And then I kind of thought about this, and I was like, I think I have like an idea on how we could do this. So what we did instead is we utilized microphones and cameras to create like a noise detection system to then like actually apply this. So we have the camera data to then apply this after. Oh, sorry, we can go back for a second. And then I'll touch on the second one too. So the second hackathon was the Tsinghua University Datathon, and this was in July 2019. And pretty much how this was is it was a fraudulent claim and bot detection setup. So what we did is we utilized natural language processing to basically detect fraudulent claims and bots in the data. And then the third one was the University of New South Wales Datathon. So this was in Sydney, Australia in September 2019. And this one was a pretty interesting one too. So basically we were just classifying clothing images, which seems pretty straightforward to begin with. And I think like the long-term business goal of this is like we were working kind of as a consultancy. And the suggestion was we could utilize the images now to then basically link like a B2C application for the consumer. And in that sense, we could then say, if you or I just posted a photo and we're wearing these clothes, the algorithm could automatically detect what the brand is and where you could buy this clothes. So it could increase the sales for those. So this was the first hackathon I was talking about, so the Internet of Things hackathon. So pretty much the premise was this, is that we had 6 microphones, and then we had an STM32 board and a camera. So beforehand, say like in the Edmonton application, they would still have the microphones, but they didn't actually have like a way to basically control the problem. So instead what we did is we used an array of 6 different microphones, and when you use an array of 6 different microphones, you can actually locate the sound source. And so from that, then if we had a threshold exceeded, we would take a photo. And from the photo, then at that point, what we did is we utilized like a, basically like a scaling algorithm on the license plates, because we knew the exact location of where the noise source came from. And then we could cut out the position of the license plates. And then from that, we do a simple like CV algorithm and detect like the numbers and the letters in the license plate. And then we were able to send out a ticket. So basically in 48 hours, we might have created something that the city of Edmonton could have done in a month. But anyhow, besides the point. Yeah, and then the second hackathon. So this was the Tsinghua Datathon. So this is just part of my PowerPoint presentation, and this is maybe to give an example of how I would typically go about a hackathon PPT. But the challenge, so how can we optimize insurance pricing while decreasing risk for UMI insurance? And then the solution was to utilize machine learning and data science to detect fraud, mitigate risks, and increase profits. And then the impact was to create a dynamic insurance pricing policy that optimizes profits, decreases risk, and detects fraud. And then just, this is a bit more about that Datathon, but kind of this was one of the summary slides for my presentation there. So just formulating the strategy as a team. I always think in hackathons it's super important to define like the who, what, when, where, why, and how before you do anything, like any writing of code, just because then you'll always understand what your consumer wants or what your buyer wants out of that. We began with natural language processing, log data mining algorithm to investigate the relationships and data for fraud detection and bot detection. And then we utilize lots of different models, essentially decision trees, support vector machines, logistic regressions, starting from simple models, and then after you have simple models, work your way up in complexity. And then we cross-validate our results and determining fraud detection strategies. And we had, in the end, a strong performing model that had great insight into development and usage. And yeah, for this, it was a Kaggle-based competition, so we actually weren't the top performing team on Kaggle, but based out of our presentation, we were awarded the first place. And then finally, because we had a good result in our second hackathon, we were invited to go to the University of New South Wales hackathon in Sydney in September 2019. So for this one, once again, just kind of going with a similar basis for my second hackathon. So the challenge, how can we use clothing images to basically determine the type of clothing and provide details on where to buy it? And then the solution was to utilize computer vision to detect the type of clothing and then connect the consumers with the business. And then the impact was to finally create a dynamic application that can increase shopping efficiency, profits, and consumer satisfaction. And then this was just a simple slide from our or not a simple slide, but it's a slide from our presentation. Pretty much we can imagine that we could put any input image of a main piece of clothing into this algorithm. And then what we did is we had a neural network. I can't remember the exact one we used, but it was just kind of like an off-the-stock-shelf CV algorithm. If anybody has questions after, you're more than welcome. I can give you resources on that too. And then so basically out of our neural net, we had 1,024 dimensional features. And we just used PCA to bring that down to the 5 most important features. And part of the competition was actually to create an algorithm that did pose estimation as well. So we actually found a neat way that we could use 5 features from PCA to cluster them together and do pose estimation. So basically based on how the person was standing, we would have those come up in different clusters. And then finally we had a class that came out as a clothing image based on the results. And so this kind of led me down to my top tips for hackathons if you guys are interested in hackathons or datathons. Firstly, as I was mentioning before, it's great to derive the business goals and the problem statement first by defining as a team the who, what, when, where, why, and how of your problem. Secondly, I think this is actually really important, and something that's been iterated to me more recently, is when we are creating something as, say, like a programmer or a data scientist or a machine learning engineer, we want to understand the user experience of our end product and continuously iterate to improve our user experience. And what I mean by like continuously iterating to improve the user experience, that doesn't mean that we add in a new feature without consulting our customer or consumer beforehand or whoever our end user will be. We want to have a pure reason for why we're going and doing that continuous iteration on our UX. And then while giving your presentation, I think utilizing consulting-based approach in talking about, say, like a challenge, solution, and impact of the hackathon is great, because it kind of gives you a bit of a purpose for what you're doing. And then I think like most importantly, no matter what it is and what you're doing, and especially when it comes to these areas, have fun and learn. Go outside of your comfort zone to network and meet other hackathon members. I'll actually just give an example. My first hackathon, I was on the first place team, and actually one of the second place team members, we came up and congratulated each other afterwards. And then what happened is him and I went for lunch the following week, and then we decided for the next hackathon that came up at Tsinghua, we would make a team together. And then subsequently that team, we ended up having the second hackathon together and performing well, and then we got invited to do a third hackathon together in Australia. So basically, a new friend of mine that I made through just networking at a hackathon event ended up traveling to Australia with him and getting to experience Australia together, which was awesome. And then in conclusion for my presentation, so firstly, my education. Growing up here in Edmonton and studying my bachelor's at the University of Alberta in chemical engineering. And secondly, talking about transforming and adapting. Basically, how I was able to transform myself from a chemical engineer into somebody who's more focused on machine learning engineering and data science now. And then continued learning, dedicating myself for an exciting international career. Actually, at the end of this month, I'm moving to Singapore because I got a job offer in Singapore, so I'm super excited about that. And then I have one more slide. I do have to go because tomorrow I'm actually doing my master's defense at the University of Alberta. But I just have, I just have my information here. I'm in Edmonton until the end of December, December 27th. If you guys are interested, I'm more than willing to meet for coffee and whatnot. I wish I would have had the time tonight to network with everybody, but yeah, feel free to reach out to me and I'm happy to meet. So thank you so much. And I'm happy to answer any questions if you have, no matter what it is.
Which project did you like the best?
For the hackathons, I felt like the first one was the coolest, just because I actually never had worked with hardware too much since I was a kid before. And so it was kind of fun getting to play with everything and seeing how it all came together on like the STM board. And I think the really cool thing about that project is we had a big team. We had 6 different team members. So at each point of the project, we were all kind of working on different things. So like first it was getting the hardware to work properly. And then we had to get our computer vision algorithms to work properly once we had the photos coming in. And then we had team members who basically built the algorithms for the noise isolation. So we had the 6 different noise locations coming in and whatnot. And it ended up just being a super fun time and getting to learn a lot. And I think like hackathons really kind of speed up your learning process because you don't really have much time to learn something. If you don't know something, you have to learn it and you have to learn it quite fast.
That first project was particularly interesting to me as well. I really liked the hardware side of it.
Yeah, actually what I had found out once we had presented this to our hackathon judge panel is that apparently Shanghai had introduced this like 2 months prior and they were getting great results out of it. But yeah, I think it seems like it's such a simple solution for a hard problem, but sometimes hard problems need simple solutions. You don't have to work so hard at it, right?
Let the technology do its job.
Exactly, yeah. So in this case, it's basically 48 hours of development and you have an applicable project that could, work on a big scale afterwards.
Miami has a similar system installed to detect gunshots.
Interesting.
They have microphones set up all over the city, triangulate within, I think, 10 meters.
Yep.
The source of any gunshot in the city. They've had their incidence of gunfire in town has dropped over 50%.
Yeah.
It's the lowest rates in 50 years since they installed the system.
It's awesome. And I mean, it just kind of goes to show is that like very simple solutions can have big impact sometimes. Yeah. Thanks for your question.
Do you think that a lot of milestones in like China, for example, might be due to just the board of the government of regulation being maybe a little less compared to North America? Do you think that has something to do with it? Is that something North America is limiting ourselves by?
Yeah, this is a really good question and something I've thought about before. I do think in regards to say like privacy, we might not see algorithms such as say like the Alipay point of system sale be acceptable here in North America right away. I think there's going to be lots of drawback, and it would essentially, if something like that was to be in place, I think people would have to give personal buy-in. Basically, it's like I'm willing to give like my facial data for this algorithm to work on my side. So that's why I think in the sense of in China, it's already going about and it can be applied automatically. But I think in North America, you'll see a lot more regulation, which is a very important thing going forward. There's going to have to be a lot of due diligence and regulation from governments across the world to basically say what is acceptable in AI and machine learning and what is not acceptable. But yeah, really good question.
So how did you
That's a good question. I think it's probably like I probably am more in kind of the machine learning realm. Basically, the reason why I put the data science title on there is my master's research. Basically, the way that I found it is more of a data science problem rather than a machine learning problem, because we have the two different data types of the non-stationary data and the stationary data essentially beforehand. If I go to it, here we are. So essentially, I found this because I'm more of like a data science-based problem, is that the machine learning algorithm could only work with this type of data beforehand. So essentially, if you put this type of data in, it would give you perfect results, and you could tell, like slow feature analysis basically gives you your slowest features, and from there, then you can utilize them to get better physical representations and understanding of your system. So in the sense of that, I found that we could basically manipulate the algorithm in a way that we could utilize non-stationary data. I kind of felt that you could put this into a bit of like a data science realm too, because essentially modifying the algorithm to include the multiple types of data.
So how important do you think that mathematics actually play a part in your application?
Pretty important. I think, for example, if I couldn't do the mathematics behind like the actual algorithm development, I don't know if I could probably call myself a machine learning engineer per se. So I think in that sense of that, if you can spend the time and basically do the mathematics and derive the algorithms from scratch, it does help you justify that change. I think though, to be honest, people will probably give you the benefit of the doubt if you can derive results. So like in my case of that, I had a good impact on like hackathons and being able to learn so much in such a short period of time. I think people would maybe give me a bit more of the benefit of the doubt on the like on the transformation.
Are you commercializing this?
I'm not so sure on the master's research yet. It's like basically actually one of my case studies is on an industrial application. And in the industrial application, it does have good results compared to other leading methods such as principal component analysis. It could perhaps be commercialized in the long run, but I think like I'm probably going to shift my focus more towards computer vision and other based algorithms when I go to Singapore.